Hello and welcome to Bodhi Unified Flow. I'm absolutely thrilled you're joining us today. Here, we have a very simple mission. We simplify complexity and amplify performance. In today's explainer, we are going to take a deep dive into a framework that is incredibly powerful, yet, if we're being completely honest, frequently misunderstood in project management. We're talking about value stream mapping, or VSM. But we aren't just going to look at the theory. We're going to get our hands dirty. We'll explore how to find hidden inefficiencies in dynamic project life cycles, and most importantly, we're going to unpack the real-world challenges and limitations you'll inevitably face and exactly how to overcome those hurdles when implementing VSM. Now, before we get into the weeds, let's set some crystal clear goals. Why are we here? Well, by the end of this session, you are going to walk away with practical, hard-hitting knowledge to optimize your own complex projects. First, we'll grasp the true origins and core purpose of VSM, going way beyond the usual corporate buzzwords. Then, we'll identify those sneaky, hidden inefficiencies that are quietly draining your resources. From there, we'll separate the textbook theory from reality by analyzing the actual structural hurdles of using VSM in highly dynamic environments like construction. And finally, you'll learn concrete strategic interventions to completely overcome those exact barriers. Here is our quick roadmap for today. We'll kick things off with understanding VSM, then move right into finding lifecycle inefficiencies. After that, we'll tackle limitations and key hurdles, followed by overcoming VSM barriers, and we'll wrap the whole thing up with a summary and our references. Section 1. Understanding VSM, Origins and Core Purpose. Okay, so what exactly is value stream mapping? Listen, VSM is far more than just a simple tracking tool or a spreadsheet exercise. It's actually an essential diagnostic and design framework. Think of it like an X-ray for your operations. It visualizes the entire life cycle of a process from the very inception all the way to completion. And it does this by tracking two very distinct streams at the same time, the flow of physical materials and the flow of administrative information. The ultimate goal here is stark and simple. We want to distinguish the activities that actually add value from the non-value adding waste. In lean terminology, that waste is called muda. If an activity doesn't add value, VSM puts a giant spotlight on it so it can be eliminated. You know, while VSM became super popular in Western industrial management back in the late 90s, its true roots actually reside deep within the Toyota Motor Corporation. And here's a surprising fact. Inside Toyota, they didn't even call it VSM. They simply called it Material and Information Flow Mapping. And this is a really crucial distinction for us to understand. At Toyota, this wasn't some abstract conceptual training aid for middle managers to look at in a boardroom. No, it was an active, rigorous engineering protocol. It was executed by actual practitioners on the floor to mandate optimized manufacturing. It's not just a map, it's a tool for immediate action. So how do you actually utilize this tool? Standard VSM methodology follows a highly systematic 5-stage loop. First, you select a specific product family or project process to focus on. You can't map everything at once. Second, you rigorously document reality by creating a current state map. You map it exactly as it is, warts and all. Third, with that map in hand, you hunt down the waste, that muda we just talked about, and you design an optimized future state map. Fourth, you propose a concrete step-by-step action plan to bridge the gap between the current and future state. And finally, stage 5. You implement the action plan. It's a continuous, powerful engine for process improvement. Section 2. Finding lifecycle inefficiencies, exposing the hidden waste. Now, when you map out your current state, something amazing happens. Distinct types of waste suddenly become glaringly obvious. I mean, think about your own project sites for a second. Are expensive materials just sitting idle in inventory, slowly degrading? What about the sheer volume of drywall or piping or code that requires rework because it just wasn't done right the first time? VSM powerfully exposes all of this. It highlights information lost in the shuffle, hidden approval lags that literally leave your crews standing around waiting for a signature, and management shortcomings like poor, disconnected planning. It brings all of these invisible resource drains straight out of the shadows and into the spotlight. Section 3. Limitations and Key Hurdles. The reality check. All right, now we have to face the music. Here's the absolute root of the problem. VSM was born in manufacturing. Imagine a factory floor. You have hundreds of thousands of repetitive products passing through the exact same recurring steps with completely static variables. In that environment, it makes total sense to map a process that will repeat 1,000,000 times.
But look at a massive construction project or any complex project lifecycle. The designs, they're completely unique. The processes, often non-recurring. The variables change daily, if not hourly. Because a building, for example, is built uniquely every single time, practitioners are understandably hesitant to invest massive amounts of mapping effort into a process that they might never repeat in the exact same way. It's a totally different beast.
And this dynamic nature creates severe structural limitations. You see, VSM relies heavily on static inventory data. Because of this, it genuinely struggles to account for the wild uncertainties of an active project phase. Because project steps are lengthy and highly variable, collecting statistically meaningful data in short timeframes, it's nearly impossible. Standard manufacturing metrics like cycle time or uptime often feel completely useless on a muddy, chaotic construction site. On top of that, the architecture, engineering, and construction industry relies heavily on highly fragmented supply chains and transactional contracts. This fundamentally blocks the kind of open, collaborative sharing that VSM desperately demands to work properly.
But wait, it's not just about the data, is it? Beyond the numbers, we hit the human element. Profound cultural barriers. Research actually shows significant resistance from seasoned operators who naturally cling to traditional working methods. Old habits die hard, especially for veteran workers. There's a massive reluctance to shift from familiar push-based scheduling, where work is just blindly pushed down the line regardless of readiness, to leaner pull systems that operate strictly based on actual demand. When you combine this incredibly steep lean learning curve with the immense pressure of tight project deadlines, well, it's pretty easy to see why so many organizations struggle to get VSM off the ground.
Section 4. Overcoming VSM barriers. Strategic interventions.
All right, so enough doom and gloom. How do we actually fix this? Thankfully, targeted strategic solutions can directly address these specific challenges. When we look at structural barriers, like rigid traditional design processes that leave absolutely zero room to evaluate better alternatives, the solution is to establish a strong guiding coalition of leadership to legally or structurally mandate VSM integration. What about knowledge barriers, where lean skills are just lacking? Organizations must bite the bullet and invest heavily in extensive workshops and exceptionally clear technical communication. And for those deep-rooted cultural barriers, research strongly suggests bringing in objective, specialized academic consultants while actively building cross-departmental engagement. You have to ensure everyone feels they have a personal stake in the value stream.
Now, what is arguably the most powerful intervention of the whole bunch? Let me tell you, it's rigorous standardization. In a chaotic, ever-changing project lifecycle, standardizing whatever you can reasonably control is the absolute master key to reducing variation. This means design standardization, utilizing uniform architectural elements and components wherever possible. It means process standardization, creating unified work instructions. Think about it. Even if the building design itself is totally unique, the way your teams pour the concrete should be exactly the same every time. Finally, engineering skill set standardization ensures you are building consistent capabilities across all your diverse teams. This standard baseline is exactly what creates the predictability you need for VSM to finally take root and thrive.
Section 5. Summary. Key takeaways.
So let's bring it all together. Value stream mapping is not a passive poster on a wall. It's a highly active protocol that visualizes both material and information flow to aggressively eliminate non-value-adding waste. Yes, applying this to dynamic project life cycles like construction introduces massive hurdles, unique designs, fragmented data, and cultural resistance. But as we've seen, these barriers are absolutely not insurmountable. By utilizing dedicated guiding coalitions, running intensive knowledge workshops, and enforcing rigorous standardization wherever possible, you can completely transform VSM from a static manufacturing relic into a highly targeted tracker of your project's ultimate productivity, progress, and cost goals. Before we wrap up, I want to leave you with a provocative thought to chew on as you step back into your day-to-day operations. Look closely at your current workflows. Knowing what you know now about the gap between theory and reality, what hidden waste will you uncover when you finally map the true flow of your next project? Trust me, the waste is there. It's just waiting for you to turn the lights on and see it. Section 6. References. Source material. To be totally clear, all the methodologies, challenges, and solutions we unpack today aren't just opinions. They are firmly grounded in rigorous academic and industry research. From the comprehensive IGLC proceedings spanning the last decade, to formal ISO standards, to Rother and Shook's foundational work, these are the authoritative sources you can check out to further deepen your expertise. Thank you so much for joining me on this explainer today. On behalf of Bodhi Unified Flow, keep simplifying complexity and keep amplifying your performance. Until next time, take care.